Welcome to the first day of GoDataFest 2020. GoDataFest is a 5-day event celebrating everything in data technology. I'm your host Jasper Gin, and today's topic is Amazon Web Services. I'm pleased to be joined today by Reynold Butter.
Hey, Jasper.
Very welcome. Reynold studied computer science at the University of Twente before becoming a researcher at Leiden University. His research was on the use of cognitive structures in scientific publications, and he defended his PhD thesis in 2012. After working over a decade as a researcher, he took a deep dive into the world of up-and-coming big data technologies at the Dutch government. In 2014, he joined GoData-Driven as a consultant in the role of chief scientist, and he took over a managerial position as chief operating officer, and that's your position today.
Yep.
You also like to mentor startups with their proposition, and you also like to lecture and do team management and operations. So you have a very busy portfolio, basically.
Yeah, I mean, I really like the buzz of a startup. I mean, in 2013, we were a startup. We were at 5-6 people.
Yeah.
And there's a very interesting atmosphere in such an environment. You really can get much done. When you start to grow, things are becoming a little bit more complicated, but then you get the execution power back. So both ways is like, but I still like to. My mom is a teacher, so she always says that I should have been a teacher as well.
Very cool. So this is the first day of GoDataFest.
Yeah,
I'm really excited. We have a great schedule for the rest of this week, and are you excited?
Yeah, really excited. I looked at the program, and it was really packed. Also today, interesting topics, interesting people to speak or to listen to. Yeah, really looking forward to it.
We're going to kick off today with a great program. We will hear some excellent presentations from experts at Amazon Web Services. We will hear from our customers. We have some customer stories from Knab and the Bundesliga. We're going to hear about mobile edge infrastructure and much more. With us now is JP Le Goaler. He is the senior manager and head of solutions architecture for Belgium, the Netherlands, and Luxembourg. And he's here to talk about the machine learning stack at AWS and the data lifecycle. JP, welcome.
Thank you. Thank you for having me. Good to meet you remotely.
Yeah. How are you holding up, JP?
Doing fine. We're doing well. Apologies for not being in the studio with you today. I actually live in Luxembourg, and we're actually not traveling as a company policy at the moment. Everybody's working from home, so that's we have to do the best under the current situation.
Yeah, but I can imagine that Amazon, with that team structure, was already prepared for this, or how does it work?
Yeah, to a large degree, we were prepared because we have a fairly flexible work culture, like most tech companies, and so we were. Most of us were already working from home partially. So, for example, I was working from home 1 day a week already. So we were all set up for home offices and using Amazon tools like Amazon Chime for video and Amazon Work Docs to review documents jointly and so on. So we had the tools and we were ready, but still it was a fairly abrupt adjustment.
Yeah. It's for everybody. It's still a strange time to be in. Anyway, you're going to talk about AI today. So I was wondering, what is Amazon's approach to AI and machine learning?
So we use a lot of AI internally already, so we'll talk about that. So Amazon, the mother company of AWS, uses a lot of AI, to optimize operations. We started doing product recommendations, like 20 years ago, I think. At that point, it was not AI, but it's changed and evolved to become AI over time. And the goal of AWS is to take that experience and offer it to our customers as a service. Just like AWS started by offering IT as a service to our customers and to simplify the entire procurement process, our goal with AI is to do the same, to offer it as a service and simplify it for our customers.
Great to hear. Well, I'd say let's start.
Exactly.
Okay, so I'm going to try to share my screen. Bear with me for a second while I do this. Okay, so I restart now. So today, we have a fairly broad portfolio of machine learning and AI, and today I'm going to talk mostly about applied AI services. So services that are already pre-optimized and pre-built to accomplish a specific task around computer vision, around forecasting, around personalization, and so on. And the reason I wanted to speak about this today is I think this is the quickest way for companies to show quick results using AI and to avoid the bit of a science project syndrome. Especially for companies that are just getting started with AI, these tools provide really a shortcut to deliver results quickly and to leverage a lot of algorithms that Amazon has delivered over the years. So talking about Amazon, we've been doing AI for a long time. Product recommendations, of course, on the Amazon.com website, or Amazon.nl, I should say now. We've been using AI and ML as well for our fulfillment centers. So it's really important for us to be able to predict sales, to forecast our sales, and to adjust inventory accordingly, but also to select the best shipping options. And that's ML powered at Amazon. Of course, with Alexa, we've been doing a lot of speech-to-text and text-to-speech machine learning that we can now offer to our customers as a service. And finally, we're still experimenting with a lot of new projects such as drone delivery that require computer vision. So we have a lot of AI and ML within the company that AWS wants to offer as a service to our customers. And of course, our customers also are very interested. I'm sure you have the same experience with GoData-driven. Our customers want to use machine learning to improve, to offer new customer experiences, for example, by offering relevant services to their customers, to improve their business operations, just like we're doing at Amazon with better inventory management, better sales forecast, and so on. They want to make better and faster decisions with real-time analytics, for example, that is also relatively new. And overall, they want to innovate, such as offering voice services through an Alexa skill, as an example, or a chatbot. So before we dive into the AI piece, I wanted to start with reminding all of us that while machine learning is kind of the very visible part, appealing part that delivers really great result, we should not underestimate the amount of work that needs to get done to deliver good machine learning results. Because of course, if you have good data sets, high quality data sets, you're going to be able to deliver good machine learning results. But if you don't, then it will be difficult. So data ingestion, storage, and cleansing and transformation are very important, and it's important to select a platform that's going to help you on this. So there are lots of different studies on this topic. They all have slightly different numbers, but typically data scientists spend most of their time collecting data and then cleaning it, organizing it, processing it. And so that's a piece that we want to tackle at Amazon we want to make it easier for our customers to do that. So we have what I call here the pre-machine learning or pre-AI data services on AWS. We have a lot of services available to our customers to make it easier to build high-quality data models for AI. So it starts at the bottom of the stack with ingesting the data into the cloud. So you can ingest over the network by shipping us devices that we call Snowball, where you can, upload 80 terabytes of data at a time, or even Snowmobile, where you can, which is a data center on wheel where you can upload 100 petabytes and then ship it to AWS. We also have like transfer services that support FTP, FTPS, SFTP to S3, streaming services like Kinesing and managed Kafka, IoT as well, which is a big source of data for machine learning, and data exchange, that is a fairly new service that allows you to subscribe to data provided by third parties. And then once you have all of this data in the cloud, you're going to create a data lake. So we have a tool to make it easier that is called lake formation. And then you will store your data into S3, our simple storage service. The first service at Amazon that went GA about 14 years ago, 2006. It's highly available. It's very durable with 11 nines of durability. It's also the most versatile place to store data because you can store any format, and the most cost efficient. So it starts at 2 cents per gigabyte per month, and you have lower tiers, colder tiers of data that end up costing a fraction of a cent. And the other tool I wanted to talk about today in this context of a data lake is Glue. Glue is maybe not as famous as S3 or Glacier for cold storage, but it's a tool that's going to allow you to build data catalogs that you will be then able to query to build and refine your data models. And then if you're already in the cloud, you probably have a lot of different databases. And one drawback maybe of the microservices architecture that we embrace at Amazon and our customers embrace as well is we've created a lot of data silos. And so what you want to do is, every microservice will have its own database or data repository. What you want to do is merge this, push this down to the data lake. But you also have the ability to query all of these data sources for real-time data using our analytics services such as Athena, which is a serverless, it's basically Presto as a service, a serverless service to do SQL on a variety of data sources such as S3 and databases using the Glue catalog. And finally, the last service I will talk about is QuickSight, which is our visualization tool that allows you to visualize your data, including the data produced by your machine learning models, and to build applications embedding these reports. So that's all the work that you need to do with your data. And once this is done, we can move to the next step, which is the machine learning stack. So we have 3 stacks in our offering. The bottom layer is going to be the do-it-yourself, where you're going to, typically for expert data scientists, you're going to pick your model, your framework, such as TensorFlow or MXNet or PyTorch, and run it on our GPU instances, and manage the entire process yourself, from creating the notebooks to eventually managing the inference. The middle layer is about Sagemaker, which is a fully managed ML service that is where you can build and train and test and finally deploy your models. I'm not going to talk about this now because there's a separate session on that topic on Sagemaker. And finally, what is the layer I want to talk about today is all these AI applied services that are already designed to do one thing and to do it well. And this leverage on the machine learning experience that Amazon has acquired over the last 20 years. And they cover, so today we're going to talk about 3, forecasting. Forecasting applies to every single business, which is why I chose it. Every single business would do better if they had a bit more foresight into what's going to happen. So forecasting applies to anyone, and Amazon has done a lot of forecasting that you can benefit from. Personalization, offering relevant products or services to your customers. And finally, for all online customers, we've all dealt with fraud, and we have a lot of experience with fraud at Amazon, and we offer fraud detector as a service as well. There are a lot of other services, as you can see, in the area of text processing, voice, chatbots, computer vision, but today we'll focus on these three. And I think that this layer allows you to move faster, to deliver results faster, because you do not have to reinvent the wheel and start from scratch.
Yeah.
So I'll start with forecast. So forecast is, you take a time series data, so data that varies with time, and based on the history and based on associated metadata, we're going to try to forecast what's going to happen in the future. So, for example, at Amazon, we use it to forecast sales. It's very important, especially as we go into the holiday season now, to forecast which products are going to sell well, and accordingly to build inventory for these products. Conversely, if we forecast a product is not going to sell well, then it's just going to waste shelf space into our fulfillment centers, and we should stock as little as possible or none at all. So we do a lot of demand forecasting for over 400 million products on a daily basis. Then in the area of delivery, whenever we ship a product to a customer, there's different routes. We can use different carriers, and what we want to forecast, we use forecasting to select the route that's going to get the package in time to our customers at the minimal cost to Amazon. And so if we do this well, both a proper inventory management, proper shipping management, this allows us to be more effective. And as you all know, retail is a low-margin business, so it allows us to be more effective and to offer lower prices to our customers. Outside of Amazon, there's many use cases for forecasting, right? So it could be your financials, your sales data, your cash flow, your payroll. Based on what you had in the past, what is it going to become? It could be real estate prices. It could be for hospitals. It's sadly a very current topic for hospitals. Forecast utilization of your ICU, for example. So again, most companies, if not all companies, can benefit from forecasting. So forecast is a fully managed service that uses the same technologies that we've used at Amazon and developed over many years. And what you need to give us is what's on the left side of the screen. So you need to give us one or several time series of what is it that you want to forecast. So we need to have some historical data for this time series, as well as any related data that impacts that you think will have an impact on this time series. So for example, if we're talking about sales, we want to know more about the products. We want to know about the price, whether it's weather sensitive, whether you have promotions. And if we have all this historical data, we're going to be able to do accurate forecasting. And once you upload all this data using the data tools we discussed earlier, Amazon Forecast, it's a fully managed service. Going to load the data, inspect it, identify the features that we need to that are going to impact the time series result. Train the models using multiple algorithms that we've developed over the years, do hyperparameter optimization, and finally select the most accurate model. That's not finally. Select the most accurate model and finally deploy it on endpoints that you can query to get your forecast. So again, fully managed service, very easy to use and accurate. So, and as an output, what you will get is a number of quantile results. So, for example, you will get the P50 result. The P50 forecast is the average forecast that we are forecasting. So we expect the true value when that happens, to be equally likely to be above or below this forecast. The P10, on the other hand, is going to be a low forecast. So for P10 means that in only 10% of the cases, the actual value will be lower than P10, which means 90% of the values will be higher than P10. And P90, on the other hand, is a high forecast. So in 90% of the cases, the true value will be lower than this prediction. You can customize this. You can ask for a P25, a P80, a P99. It's up to you.
Yeah, and if you were going to choose one value, which one should you advise?
Yeah, so if you were going to use only one value, my advice would be the P50, because it's the average value. So again, that's our best prediction with the data we have, because we think that it's equally like the actual value is equally likely to be a little more or a little less. So I will choose P50. And if you want to choose two, I will take P10 and P90, because that gives you an 80% confidence interval.
Makes sense. Yeah.
Okay, so let's move on to the next service, Amazon Personalize. This is using the same technology that we've used at Amazon for many years around personalization. So this is an old screenshot, so I apologize for the resolution here, but for a long time we've been giving customers information such as customers who bought this, the item you're looking at, also bought that. So this has become a staple of e-commerce, not only at Amazon, but everywhere. So this, initially, this used to be rules-based, but we've incorporated machine learning, because with statistical models, you can't take into account all the parameters that can influence this. So the benefit to any business here is to be able to help customers discover products and services that they need and that are relevant to them. For example, if I'm a bank customer, and let's say I don't have a lot of money on my account, I don't think you should recommend to me investment vehicles, because I don't have any money to invest. So, it's kind of a wasted recommendation. But maybe you want to recommend to me a loan, because maybe I need more money. Vice versa, if I have a lot of money on my bank account, I wish I did, you should then recommend investment products to me. So this is a simplistic example, but I think a lot of online businesses, or nearly all online businesses, can benefit from having more targeted, relevant recommendations to their customers that will improve customer engagements and in the end increase conversion speeds, subscriptions or downloads or whatever you're trying to propose to your customers. So Personalize solves for these three things. The first one is user personalization. So you give a user ID, and based on their history, it's going to propose the most relevant items. By the way, it also works for new users. If you have new users, there's zero history by definition. In that case, it's going to propose the most popular products. It's also going to propose similar items, as we just saw. Customers who bought this also bought that. And personalized ranking, which is going to rank a list of products for a given user based on their history. So just like Forecast, it's a fully managed service. The key is to input quality data sets around the data you have around your users. So what pages are they viewing? What are they signing up for? What are they buying? As well as metadata around their users and around the services that they're offering. And if you can provide quality data here, that's key. Amazon Personalize, in a fully managed, very easy fashion, is going to inspect, identify the features, train the models, and eventually, based on the algorithms that Amazon has developed over the years, build a custom model for you that you can then query by API. As an example of a customer, Coursera has implemented Personalize to make better recommendations for new training. So if you take a training, they've improved the suggestions for the next training you should take, and they've seen a quite significant increase in people signing up for new trainings, and therefore a quite significant increase in revenue as a result. And the last one I wanted to cover today is fraud detector. So unfortunately, there's a lot of fraud online, and at Amazon, both for Amazon Retail and AWS, we seem to be attracting a lot of people who try to fraud. So of course, at Amazon, people are trying to get products without paying for them, and at AWS, they're trying to get computing resources without paying for them.
Yeah, I can imagine.
So we have really a lot of experience in combating fraud at scale. For example, new fraudulent accounts, fraudulent payments using stolen credit cards or using prepaid credit cards in the case of AWS, where you bill at the end of the month. So some users will sign up with prepaid credit cards with a very low amount on them, and of course at the end of the month we can't charge them. Guest checkout, if you have an e-commerce website and you have a new customer, obviously you don't have any history about them, but we've developed algorithms to try to identify the ones that are most likely to be fraud. Yeah. And any kind of loyalty program abuse, like in the case of AWS, the AWS free tier.
Okay.
Unique. Okay, so how it works, it's similar. Again, all these applied AI services are similar in the sense that you upload your data. So in this case, you actually need very minimal data. What you're gonna need to give us at the very least is an IP address for your users, a timestamp, and whether the event was fraudulent or not. And then we'll upload all of these, and we will enrich the data. For example, if you give us an IP address, we will infer what is the location. If you give us a credit card number, we will infer what is the bank offering it in which country, and these kind of things that allow us to enrich your data to make better predictions. And the way it works, we use a combination of supervised machine learning. So supervised machine learning is all these parameters that you give, and then you give us, for example, users with their location, their email, the time it happened, the payment information, and you tell us, was it fraud, yes or no? So that's the labels, fraud, not fraud. And based on this information, we're able to build our models, or your model, I should say, and we also supplement this with unsupervised machine learning to detect anomalies. So anomaly detection can be done without any label data, and we do that on our own. And once we have built the model based on the data that you gave us, you're able to see it, able to see the overall accuracy, and also if you, for example, the model is gonna, for every call that you make to the model with a new, question, is going to give you a score that's going to be between 0. 0 means very likely to not be fraud, and silent, which is definite fraud. So if you set a threshold at 500, for example, you can see how many false negatives or false positives can I expect. And in the tool, you can actually move this around and see how this impacts your false negatives and false positives. And then you're going to take this and build some rules in your applications and decide that, for example, if the score is above 700, I'm going to do some manual verification. And if the score is above 900, I'm just going to deny the purchase because it's too likely to be fraud. So the way it works, we deploy, just like the other services, fully managed, highly available, auto-scaling endpoints. And you're going to make an API call with the data you have, and we're going to give you an outcome in the form of an ML score. So just to summarize this, I'm very fond of these AI services because they can help you deliver impactful results quickly. They fully manage, they're accurate because they leverage the algorithms we've developed over the last 20 years. They're very easy to use. You just have to bring your own data. And in the end, it's based on your data, and we develop custom models just for you.
Interesting. So, what is the roadmap for Amazon on AI? What are your plans?
So I wish I could share a lot, but actually I'm not allowed to share publicly our AI roadmap, and I don't want to become famous for spoiling the keynote of our CEO at reInvent. But what I can ask you to do is be just a little more patient. We have reInvent coming up, and this year it's fully virtual. It's also free. And it's going to be a 3-week event with lots of announcements around AI and around many other topics.
Interesting. Yeah.
And maybe one last thing, if I may, my call to action is if you're not in AI yet, try it. There's using these applied AI services, you can get results quickly. We're here to help with our solutions architect. We do immersion days, we do workshops, and partners such as GoData Driven can, are machine learning partners that can help you speed your projects a lot. And we've seen that we don't have AI on it yet, or confidence scores, but we've seen that when we engage a partner, the outcomes are a lot better than if you try to do it on your own, especially if you've never done it before.
Thanks for that, JP. Really looking forward to hear news about the roadmap, of course. I'm going to be there at the reInvent. Thank you for explaining how Amazon is using their own experience, package it, and make it easy to apply in the day-to-day business of their customers. Really interesting to listen to. I want to thank you very much for taking the time of being part of GoDataFest, even there in Luxembourg, in these strange times. Looking forward to see you somewhere, perhaps next year.
I can't wait. I used to travel 4 days a week to Amsterdam. I'm missing my time there and all my teammates. So can't wait to go back. Hopefully we'll go back to something more normal fairly soon.
Thanks, JP. It was great to have you here.
Thank you, and feel free to contact me if you're listening and you have any questions. Feel free to contact me. I have my email address on this slide.
Excellent. Thank you very much.
Thank you.
Wow. That was an illuminating presentation.
Yeah, like I said, I really like the way they package up their own experience and provide it.
It must be great for, like you said as well, like smaller companies or mid-sized companies that are just starting out with AI, or...
Yeah, true. I mean, many companies don't have the time nor the resources to have their own data scientists, but they can build on this type of experience, deploy it easily, and use it in their day-to-day business with almost no friction. Yeah.
Do you know if GoData Driven ever uses these kind of services? Like, do you see a demand for those with your clients?
More and more. So back in the days, we saw that a lot of things were needed to be invented, right? But now we see a lot more pre-packaged, very valuable tools to be used, really to get a quick start, right? Yeah. You can always try to improve afterwards, but you should get to that value first.
Yeah,
I think these types of services are really wonderful to do that.
Excellent, yeah. Next, here to talk to us about building data lakes and account vending machine are Peter Zuidam, Head of Systems Engineering at Knab, and Jeroen Koopman. You are a DevOps engineer at Knab. Welcome.
Thank you very much.
Thanks for being here.
Yes.
Yeah, wonderful. And that you're live here in these circumstances. I mean, that is really, really nice to have you here live in the studio. So, let's start with the general question. What does the IT platform team do?
Yes. So that started out about 3 years ago, Jeroen?
Yeah, we joined Knab together, I think, right? At the same time, basically.
Yeah. in 2017 it was.
Yeah.
So more or less coincidental, but we both, and not to forget our colleague Midas Vult, he also started at that time. We all had the vision of helping Knab getting into the cloud. So we started a IT platform team, me as the head of system engineering, but also in the role of a product owner for the platform, and Jeroen and Midas as the DevOps engineers for this platform team.
We all had a lot of experience when it came to all the hosting environments, basically. So from that perspective, we said, well, we know at least the struggles when it comes to on-premise environments, such kind of things. So I think what we can do is deliver a lot of value within Knab and make change with all kind of struggles we don't have to face in AWS anymore, or at least in the cloud anymore. So we started off with, well, you as the product owner, of course, and we said, well, we want to do something with security, logging. We need to ensure we are in control when it comes to monitoring. And the biggest advantage, I think, at that point in time was to, well, don't think and struggle with capacity management, right? So we can just start off as we, well, wanted to. And yeah, I think that's the main, well, how do you say, the direction we started with.
Our starting point.
Yeah, and I can understand that cost and ease of deployment should also be principles that are part of it.
Of course.
Yeah. Well, cost maybe was not the first thing. Of course, it's important, but I think security was. We're a bank, so I think cloud, and we proved that can really help you make your environment more secure, but also more auditable. Every change is in some log, being secured on a isolated place for the security department or the auditing department to check, or DMB even. So we really saw benefits of using infrastructure as code and all these kinds of methods and ways of working to benefit for a bank like Knab.
To help the bank, the way I know Knab, of course, is that it is a bank that wants to change how banking works. I can't imagine that it doesn't have an effect on the organization as well. Perhaps you can shed some light on that as well.
Yeah. Of course, if you talk about the platform where all the software lands, it's quite far from the end user or the customer. In our minds, I think we really wanted to help out the Agile team to speed up in their delivery so they can help their customers. I think one of our nice examples for that was in the time we had to do user consent management. And in the normal days, even getting a server would cost us around 6 weeks, and it would also cost us quite some money to get that server up and running. And we had our first version of our cloud platform. We had a team who was able to work with AWS. They also were experienced. I think in the time where we only could get that server, we had it running. We had from zero code into an application, entangled into our website. And one of the nice parts also was we had to test it because it needs to be secure. So we did this penetration test. Also, again, there was the benefit of infrastructure as code. So we really made a copy of our system. We went, I think it was here, where we did the penetration test together with Binks. And we had our findings. Next day they were resolved, they were tested, and it was ready to go. That was super fast.
Yeah, well, I think in the past that kind of penetration tests were done as well, right? But then it's just, something written in the document, so you will have your SLAs, and a change or whatever could take up to 5 days. And now it was solved at least within, I think it was even 12 hours or so. And that's the whole idea. And especially when you want to be and remain dynamic. And we, from a platform perspective, had so many stakeholders with this was just an example, but with all kind of different needs that in the end, if you want to remain at a traditional company, you will never make it, right? You won't survive on the long term, I think. So,
yeah. So it sounds like selling the why of cloud came really natural for you, but also for the Knab organization, because you were able to show the advantages really quickly and naturally, right?
Yeah, it was. Yeah. So we stepped in at the right point in time, that's for sure.
Of course, IT is always a very dynamic environment. There are new services, new ways to implement solution every week. How did you went about that?
Yeah, I think the dynamics of Knab weren't only on the level of IT progressing, but also on the business level. I think we want to help our customers, give the human touch, so make them worry less about their money business. Mm-hmm. So we are constantly looking for solutions, helping our customers out, and that really gives a high dynamics, because at one point you want to use the information of our customers to help them or sell them other services which we think they want and need. So there's a lot of product development going on at Knab.
Yeah, at the same time.
Yeah, and as things go, some are successful, others are not. So you need to be able to bring it up to speed, time to market. But if it doesn't work, you need to break it down. And you don't want to have costs for a year or 2 years because you spend money on a server or money on something.
You just want to change fast, and it's kind of annoying if you want to change. But in the end, like we just spoke, right? There are contracts that will just make it hard to change.
Yeah. So, for instance, I think if you do automation, if you do infrastructure as code, it's very easy to bring it up, but it's also very easy to bring it down and destroy it and get rid of it. So that's really where the agility comes into place.
And then we have to say, I think at that point in time we started to build our platform basically, and we started with, let's say the 3 of us, but in the end it's all written in code indeed. So everybody within the organization that can read and understand that code can make change, and that's the whole idea, right? They can make change. And in the end, we were able to learn from them basically, and speed up in the process as well.
Yeah. So that also means that if you want to move fast, you have to give people access to their to services really quickly. So accounts need to be easily given out, but also in a secure and compliant way. Yeah. How did you go about that?
Yeah, that's a good question. I think there we came up with the concept or the service we call account vending machine. And this account vending machine, I think, if you look at the picture, also people at home, basically in the top you see a number of agile teams, really dynamic. The structure of the teams change more easily than the services. So they just want to have accounts where they can deploy their software in. For us and for Knab, it's also important that it's safe, it's auditable, it's the connection, the networking, all these services are there, because this agile team just wants to build software, and so platform team needed to think of a way how to help them fast. So that was account vending machine. So teams came to us, say, we want to start, for instance, data lake, and we need accounts for that. Okay, give us your information, give us your budget, your requirements, and our account vending machine would, like a slot machine, hand out all the accounts you wanted to have for your staging, for your production, and work. For us, account vending machine was a way to keep all these accounts consistent, because the first account and account number 100, we really changed our platform, improved it.
So within how do you say, a basic account, I think all of the ingredients were basically in there, right? So identity providers were provisioned, so people were able to authenticate. So we provisioned the proper roles in there, the proper Lambda functions that will just describe or subscribe basically all the CloudWatch environments and send them to, well, basically our central pane of glass. So security can just look up flow logs, for instance, and see, well, what's happening within a network. So that does imply the VPCs were provisioned in the same manner, basically. And based on those, I think, account vending machines or pipelines, I should mention, people were in the possibility to just inject the routes, etc. as well. So,
wow, interesting. When preparing, you mentioned the concept of blast ratio, radius.
Yeah.
Can you perhaps explain that a little bit more and why it's important for a bank?
Yeah, so there was this conflict between being very secure and strict and giving the teams as much freedom as possible. So we found a solution in not using one account for, let's say, production, where every team goes in and changes, and it's very hard to, mitigate the risk of failure of one team that is impacting another team or impacting the whole of Knab.
Yeah, so when you come back to the vending machine, you say, well, we have, let's say, a staging and production account. Those accounts are decentralized and are provisioned for a specific need or well, let's name it an initiative. And I think every account or every initiative we will provision can act on its own. So everything is decentralized and everybody can do whatever they want within their needs while they take their own budget in account, because in the end they're still account owner basically, or initiative owner of those accounts provisioned. So that's the whole reason behind it.
Yeah, to summarize, it's the highest form of segmentation using a single account. So if you make a boo-boo in your test account, it's only your team that feels it, not another team. Yeah.
Interesting. And you already mentioned some of the components of the account vending machine. Yeah. Can you tell a little bit more about that, perhaps?
Yeah, sure. You want to do it?
Yeah, well, like I just explained, everything we have provisioned for a team is in there. So subscribing to all the CloudWatch logs, enabling the VPCs, creating transit gateway attachments, provisioning the routes in there, provisioning the roles in there. I think every component we need to deliver to a team has been provisioned within that account vending machine. And the whole idea behind the account vending machine was more or less, let's say what will happen if a data center or so, an availability zone or a region won't be available. Well, that's something we all think about, right? But what will happen if the entire organization or all the accounts we have in place won't be there anymore? Then how are we going to solve that? And the whole idea about account vending machine is, well, it doesn't really care, right? We can just create all what we have based on the pipelines we have provisioned into just a new account, and that new account will provision all the others and all the other initiatives. So within the teams or the agile teams on the board, people can just provision their code again. So the only thing we really need to take care for is the data, basically. So the data is cross-regional and so on and so on.
Yeah, we went as far as even putting the budget into code.
Yeah, wow. Indeed.
Nice.
So even as a product owner, I had to write code and put it in a pull request, and the others would approve it. And the end result was that the team would get a report about their budget and if they were reaching it or if they were over budget. So they were also in control of their own cost. And from a business controller level, we could provide business controllers with the big one, but also segmented towards accounts and towards teams. Yeah. Hey, this is not going like we want to. But the team could make the trade-off in saying, you know what, let's accept this higher cost on AWS, but because we want to put our development onto fixing this bug, and then you put the decision in the hands of business to say, do we want to spend this money on AWS or on the developer? So quite powerful.
Oh, wow. Nice. You mentioned infrastructure as code a couple of times. It seems like these software engineering principles are really embedded in your organization. So perhaps also the CI/CD process is really integrated in this whole. Can you say a little bit about that, perhaps?
Yes. So basically, last year we were also building our pipeline vending machine.
Mm-hmm.
So teams were not only getting an account and networking, but also the whole CI/CD tools like versioning, the repository, the putting it from one stage to the other. Maybe you can tell me more
what we
about
just exposed is you have a lot of native services in AWS, right? And those services we embedded and we made them basically as modules. And those modules can be used within other teams, and likewise we use them in a common way. So those modules will be, some of those modules could be used to provision pipelines, and I think others will be used to create whatever they need, basically. So it's the ideology of having those modules as components and using them all together. And in the end, people were using pipelines in AWS, but there were different ways to use pipelines as well. So CI/CD was in there. Mainly, I think, from our perspective, so from the platform perspective, that people can make change, it's visible, and they can just inject the needs for them. And we as a platform will just approve basically their pull request to get that stuff done. So there was always a way to have first principle when it comes to changes within the platform, basically.
Again, getting to that compliance, security.
Indeed,
Wow.
So could you maybe summarize for us the results very shortly?
in general, time to market. So being able to deliver end results within weeks instead of months.
Mm-hmm.
Within data lake, we didn't discuss that much, but the start out was also already in AWS, but things progressed. So we saw a big chance for serverless. And we were able to cut down the cost to 20% of the original, but more importantly, make analysis much faster than before.
Right.
So then it's at some point even hard to say, okay, did we manage cost or did we manage to do a lot more analysis? In practice, we see in data lake a lot more usage than before because it's much easier to use. Yeah.
So you actually you brought down the costs and you sped up your analytics. So there was no downside essentially.
Yeah, indeed. Yeah, we our tagline was cheaper, faster, more secure.
Yeah, who wouldn't want that?
On those three items, we really brought the results to the organization. Yeah.
Excellent.
Great. Yeah.
One thing to add, when it comes to security, and I don't think we spoke about it, but in the past, when you had your environment running on-prem, connectivity was, just allowed basically, right? 90% of all communication, I think, maybe it's my perspective, but was unencrypted. And I think when you head to the cloud, you will just re-evaluate, what kind of communication do we have and do we want to have it secure? And in the end, yes, of course. So overall, you will get way more secure for data lake, but also for all the other components in there. So it's the best steps to make, basically. Yeah.
So it sounds like that apart from bank turning it around, becoming Knab, you also showed this example to other banks, perhaps, that the step to cloud is not necessarily more insecure, but just the other way around.
Yeah.
It gives you more tools to become even more secure, compliant, consistent, and more customer friendly as well.
It's just change that makes it complex, right? But
Well, thanks.
Great. Thank you very much, Jeroen, Peter. Thank you for being here and for sharing your experience.
Thank you.
Thanks. Thanks.
Okay.
Blijf nog even napraten. Even wat nashots. Wat we daar zeg maar. Nee, doen alsof we een beetje.
Ja, dat opnieuw.
Nou, ging redelijk. Ik kan de timer niet zien, dus dat is. Zo even kijken.
Ze dachten dat.
Ik bedanken en dan starten wij meteen bumper in.
Oké.
So thank you very much, Jeroen, Peter, for being here and sharing your experience. I really enjoyed learning about how you do things and how this has helped you to go to the cloud. Yeah.
You're welcome. Thanks very much.
Thanks for your time.
Thank you.
Wow, that was a great first half of today's session.
Yeah.
Yeah.
Interesting stuff.
I really enjoyed JP's talk about applied AI and using these different AWS services for those.
Yeah.
And I thought it was very interesting to hear about these automated vending machines.
Yeah, the account vending machine. Yeah.
Sorry, the account vending machine.
I mean, it's really wonderful to hear how the cloud actually brings about that ease of use, the really putting a service to its use for a particular use case, right? You can choose so many, but so you have a lot of options. But also to hear that cloud actually brings more transparency, compliance, security.
Yeah.
Because you can script it, you can use infrastructure as code, you can apply all these software principles to it.
Yeah.
Really illuminating this morning.
Yeah, I really enjoyed it. So, Reynold, do you know that the GoDataFest has its own band?
I heard about it. Yeah, wonderful.
Yeah. So they're all engineers and data scientists who work at GoData and they've never played together. But for this week, they've composed a song, and throughout this week, we're going to check in with them to see how it's going. But I'm very curious to see how it is going. So let's check in with them.
Awesome.
Okay, let's try. I will do a couple of small on the drums, but when I do a big crescendo, then we start.
Hi, I'm Alexandra. In this band, I play drums, but normally I'm a data engineer at GoData. That's me.
Hi, I'm Bas Bela. Work as a data engineer at GoData. And I've been playing piano, mostly classical piano, since I was young. Been in a pop band and did some songwriting when I was at university. And now recently focusing on, composing classical music again.
Well, I'm the only scientist between the engineers of this couple. I've been playing guitar from my 16th. Played a lot in metal bands, so if you don't like the end, that's probably because I exerted a little bit of influence on the song.
3 times, huh?
3 times.
I only did it twice.
Me too, I missed one iteration. Okay.
Let's call it jazz.
That's the only jazz.
Yes.
Why not?
It's some style of jazz, unknown yet.
GoData jazz. Let's call it like that.
Exactly.
Wow, that's they're really getting along for people who have never played together.
Oh wow, that already sounds great.
Yeah, it still needs some work, but I'm sure we're by the end of this week it's going to be a hit.
Yeah.
Great. So, second half of today's session, we'll hear more presentations about edge infrastructure and AWS Wavelength, deployment of machine learning models using AWS Sagemaker, and how to stay in control of cloud. But first, we're going to go to Luc Figor. You've joined us here at the table, and you're a data scientist at the AWS Professional Services team. Welcome.
Yeah, thank you, Jasper. Also, very happy to be there, and thanks for the invite.
Yeah.
I'm going to talk a bit about sports today.
Yeah.
Great.
Are you a sports fan yourself, by the way?
I am definitely.
Yeah?
Yeah, definitely. So I've been passionate about sports since I was very little, for a really long time, and also played quite a couple. So I played lacrosse, basketball, tennis, horseback riding, several esports.
Wow.
You name it, and I probably played it. The only problem was that I was not as good as I wanted to be, right, in sports. So which is okay, unless you're pretty competitive. So it would just eat me up. It would just eat me up. So at some point, I started analyzing sports more and more to understand what was going wrong. Mm-hmm. And this hobby basically got out of control. Yeah. And we're going to talk about that also today. Awesome. What I'm doing now at AWS is also helping our sports customers actually to develop, to analyze athletes, cars, and teams, and find what gives them the edge on their opponents.
And today you're gonna talk about how you work together with the Bundesliga, right?
Yeah, exactly. Right. So how we show what those players are doing on the pitch and translate that into insights that we show to fans, millions of fans all across the world.
Yeah. Great. So great to have you here. And how does AWS for Bundesliga look like?
So. AWS in sports in general is really sports is one of the greatest storytelling platforms that we have in the world. And at AWS we've been working alongside leagues, teams, and broadcasters for quite a while, helping them really use AWS services to better for digital transformation, to change their customer experience, to use analytics, and also machine learning in that way. And right now, that is actually with the Bundesliga. We're since recently we started also a partnership with them to help them also transform their business and to become the most innovative sports league, soccer league on the planet.
Yeah, I mean, there are a huge number of fans in the world for the Bundesliga, so I can imagine that the impact on them is great, right?
Yeah.
Being able to give those insights, etc., back to the viewers.
Yeah, definitely. So you will see also in our collaboration, it's really centered around 3 different pillars. And in one way, we really want to help the fan, engage the fan and delight the fan with real-time insights from the game, and to help them more and more understand what's happening on the pitch. Not just the events that everyone can see, but also what are the tactics behind, what are the coaches trying to let their team do. The second pillar is really to enhance the broadcast product. And this is to how do you support different formats, right? How can you watch the game everywhere on your mobile phone, or how do we support like the expansion worldwide so that everybody in the world can see the Bundesliga? And thirdly, I think also a very important pillar that we sometimes tend to forget is how to improve business operations, building services to reduce development cycles. Automating processes and enhance the use of data to reduce costs. But today we're talking about the first pillar, how to engage and delight fans.
Definitely, yeah. So like you said, it has these different pillars. We're going to focus on the first one first. In general, what from a high level perspective, what elements are part of AWS for Bundesliga?
Yeah, so what we what we really try to do with this engaging and delighting fans is that gave birth to the Match Facts project, the Bundesliga Match Facts, which are real-time statistics that we show within the broadcast and on their digital platforms, and here highlight specific performance. And what that looks like at Amazon, we like to work backwards, so we like to start with the result in mind. So I got a small video of
nice.
What that looks like.
It's a first in world football. How high is the likelihood of scoring a goal in a specific situation? How do teams change their tactics? The new Bundesliga Match Facts, powered by AWS, are created live during matches through machine learning, artificial intelligence, and innovative cloud technology. Expected goals, or X-goals, help to calculate the likelihood of scoring for each shot in the game. The machine learning algorithm was trained by analysing more than 40,000 shots on goal and can precisely determine the goal probability of all different kinds of shots. The calculation considers the distance and angle to the goal, pressure from opposition defenders, and the goalkeeper's position. The speed of the player at the moment he shoots is also crucial.
Yeah, I could watch it all day, but
I can imagine that having to watch those images of your favorite sports must be a real chore for a lot of people who help to train those images. That looks really exciting. I'm almost getting looking forward to watching a match. So that is the final product, but how did you connect all these different parts? I mean, that must have been a huge setup.
Definitely. So what the first two Bundesliga Match Fact we released at the end of last season, actually right after the Bundesliga started as the first league again after the global pandemic. And we released two match facts in there, and I'll have some videos of that later on. But one is expected goals, where we show the probability of a person scoring a goal from the position that he shoots. And the second one is average positions, which shows really not the position, the lineup that you see on TV, right? What the coach fills out, but by tracking those players to show where they are actually playing. So to show that tactical plan of during the match. And this starts all with the cameras on the fields. So as you can see also in the overview, you have the soccer stadium or the football stadium, where you have about 16 to 20 cameras placed around the pitch. And all those cameras are using computer vision to track each individual player, as well as the ball and the referees around the pitch. And that turns into positional data. And that positional data is then sent to the DFL itself, and is the input that we start using also in our machine learning models.
Okay. And of course, we GoDataFest is about technology. So can we dive a little bit deeper into how the AWS architecture was set up?
Yeah, we can. Right, it starts with this live data, these live positions data, as well as event data. So there are two different components there. Mm-hmm. And we stream that data, we ingest that through WebSocket in AWS Fargate, which is a serverless container managing your containers, basically. So here we do our feature processing. So think about it that you get about 25 frames per second, which contain all the positions of all the players. So 25 photos, right? And in those photos, every player on the pitch has a specific location as well as the ball. And from that, we have to generate features. Like if I'm going to ask you how to predict if someone is going to score a shot, what are you going to say?
Yeah, look where he's going or where the ball is going, right?
Yeah, exactly. So location of the ball, distance to the goal, angle to the goal, position of the goalkeeper, also the pressure that person is on. So all of these features we have to compute based on that incoming positional data. From that, we basically create a record, and that record then we send to our models that are trained in Amazon Sagemaker. We train them offline based on 40,000 shots. And from that, we have a model that we then deploy within Amazon Sagemaker. And during that live game, we then send all these events to the Sagemaker endpoint and then get a prediction. What is the likelihood of scoring? We store all those events basically in a serverless database, which is a key value database, which is Amazon DynamoDB, that can easily scale up or down when needed. And when we need to send a certain event, in this case, when someone scores a goal, we then send it throughout Lambda to the systems and to all the different devices out there.
Okay, interesting. And of course, you already trained the model before. I can imagine that you want to keep improving the models. Is that also part of this setup, or do you keep applying the same type of model?
So if you look in the lower part also of the graph, we store all this data from all these matches we store on Amazon S3. And here we just build this large, in a way, data lake of all matches and all shots and all this data. So we can use this data actually to also improve models. So if we see something could be improved, are there certain situations in which we would expect a different goal probability, then we retrain this model, we deploy it simply, and then our live pipeline hooks in back into this model. And I think one of the most important parts here to see that it's really composed, right, of all these different components, this whole architecture. It's not simply just building a model, it's not simply deploying the model, but it's about how do you ingest data? How do you process data, live data, in real time? How do you restore your events in a live situation, but also how do you store your historical data, and how do you send that out, all in a serverless manner, in a way that it can keep up with the processing, but at the same time also is very cost efficient.
Yeah. Of course, this morning already we talked a lot about the cost effectiveness, the flexibility. Is that also a factor here in this setup? The flexibility of the setup, does it change, or is it something that you settled upon, it works, and you just keep improving your results with it?
It's definitely something that we take into account, and especially in sports, right? It's the nature of it. It needs to be scalable because you typically only have games over the weekend. So why have an infrastructure lying around all week that you're not leveraging? Yeah. Sometimes you have one match, sometimes you have 4 matches, sometimes you have 9 matches in parallel. So how do you build something that you can just easily scale? So for example, in this architecture, what you see is that our Amazon Fargate containers, we have 1 container running per match. So for us, it doesn't matter how much matches are played at the same time. And you're only paying for what you're using at that point in time. At the same time, we can balance the load on our Sagemaker endpoint to start additional endpoints if needed, and our DynamoDB instance just scales up automatically or scales down.
Yeah, nice. So, what does the result look like?
I'm very curious as well.
Yeah. Let's go through it. All right. So I brought 2 videos to show how it looks like in the broadcast and how it looks on the device itself. So the first of the match facts, which is the average positions. So here to really show what's the actual location of players on the pitch. So
nice.
Let's run it. So as you can see here, we have the Dortmund versus Bayern match, and this is the lineup that they initially started with, that they highlighted. But by tracking the positions of players, we can average their position across the pitch. So you see that in the top left, the lineup is actually very different than what originally was shown. You can see here that Bayern is playing actually pretty offensively in this way. And at the same time, this is shown in the broadcast, and it can be shown also at several times actually, that what is the location right now. is a team playing compact, or is a team actually playing very offensive? Do they move forward, or do they move backwards? To really allow the viewer to see what are the tactics behind it, right?
Yeah.
And on the right side, you see actually the phone, which is the Bundesliga app. And in that, you can also see all these insights by just toggling the average positions or the real or the highlighted positions at the start of the game.
It feels like you're really adding to the experience of the fans out there. They're all experts, but now they are getting even more information on why their club is doing either great or not so great. Yeah, interesting.
Yeah. Yeah, so the second one that I brought is the second metric that we released is the expected goals, and what we do there is I think the example that we also took is from a shot at goal. What's the probability of that shot going in? So with this, we want to show, the amazing shots that players take and the likelihood or the unlikeliness of that shot actually going in. So maybe we can also have a look. So again, this was the game Dortmund versus Bayern. And here you see actually a bit of a combination. There we see a shot, an amazing lob over the goalkeeper with a lot of... And then we get, after the goal, we get actually the probability of that shot going in. So you see that there's only a 6% shot actually that Kimmich would score this goal.
Wow.
And that's because, as you can see here, the things that we compute, right? We compute his position right there. Then we see the pressure that he's under, how many defenders are close, how many defenders are between him and the goal, what's the position of the goalkeeper, the angle of the goalkeeper there. And then we look at what's the likelihood of that shot going in. And it was actually really, really low.
Yeah.
But it was the game-winning shot in that case.
Oh, nice.
And I think the cool thing here is that you can do a lot with this probability, right? So if we look, how we use this is that you can sum that probability of all shots during a game and compare that across teams. So then you suddenly get an overview of which teams had more chances, which team should have won, instead of the regular things like ball possession or amount of passes. You start to see which team actually created all the opportunities, so to say. And in here, if you look at the app, you will see that's tracked in live. It's on broadcast, it's shown at the end of the game, but in the app, it's actually shown live, where we show the sum of all the XG, expected goal probability values, and then you can see which team is actually the better one. In this game, it was actually really, really close. They were about the same probability. So you could say that maybe neither team was supposed to win.
No,
but Bayern did.
So I can't imagine that you're done, right? So what kind of other features are you considering to implement?
Yeah. So we have these three pillars, right? I just showed you an example how we are helping the Bundesliga to delight their fans. We're also helping them to improve their broadcast product by creating a serverless streaming platform, helping them create a serverless streaming platform that reduces their cost by 75%. We're also helping to improve business operations by automatically, within their esports division, their FIFA league, by tracking automatically their stats and tracking a lot more stats and reducing actually that time to also capture them. So in many ways, we're trying to help them to become the most innovative league in the world. And we're doing this by leveraging all those different services to help them build these new products. I think the main message here also, I think, which you shortly saw also in the architecture, all these solutions, they are not simply just a model. They're not just about model training and doing that just a bit faster, or they're not just about model deployment. They're about using different services to create a solution for a product, and by that help the Bundesliga to achieve their vision.
Okay, nice,
great.
I think, the last thing I brought for you, actually, it's quite the timing of the event, because we actually launched last weekend a new match fact.
Oh, nice. So we have a scoop, Jasper.
Excellent.
Which is called Speed Alert. So I brought a little video of what that entails.
Oh, nice.
Wonderful.
To be one step ahead. In football, it can literally make all the difference. Speed is of the essence, and from now on, Bundesliga Match Facts, powered by AWS, has it covered. The Speed Alert determines the fastest player in every game, simultaneously noting whether it's a personal or team best, or even a league record. In this instance, Dortmund's Erling Haaland accelerates to over 35 kilometers an hour on his way to making it 3-0 against Gladbach. That's almost 10 meters a second. But you need pace at the back as well as up front, and Alphonso Davies is best in class, the Bundesliga's fastest player on record. He even topped 36 kilometers an hour last season, along with Leverkusen duo Moussa Diaby and Leon Bailey. Full throttle Bundesliga, now diligently documented thanks to AWS.
That is great. Nice to see.
Wonderful.
Yeah, great. So, to wrap up, I think we have shown an awesome example of how data and AI is not something just for business. Of course, it helps the Bundesliga as well and the businesses within that, but it also enhances and impacts the experience you have with something as common as sports, right? So that is really wonderful. Thank you very much for that.
Yeah, glad to help, and I think Nas will tell a lot more how to do that actually, how to deploy that more, but I'm glad you enjoyed it.
Luke, thank you for being here. Yeah, our previous guest already mentioned Amazon Sagemaker, and here to talk to us about this a little bit more, how to do model deployment using Amazon Sagemaker is Nas Levant. Welcome.
Thank you for having me.
Great
to have you here.
Yeah. So you're going to talk about all we're talking about the machine learning stack, Sagemaker, model deployment. I mean, I know from experience that it's a really iterative process, right? You need a lot of trial and errors. Are you going to get us through that type of process?
Exactly. So I'll be talking about what are some problems you might have during your machine learning training and deployment process. And it's usually not only about training and deploying a model, it's usually about how you can have a full solution end-to-end in a pipeline.
Yeah.
So I will be finishing up with also some supportive services around Sagemaker, which you can use to build an end-to-end solution.
Okay, great. Looking forward to it. Yeah.
Great. I'm also looking forward. I prepared some slides for you.
Oh.
So if you don't mind, I would like to start sharing them.
Yeah.
Excellent.
Go ahead.
Great. So first I would like to start with talking about where Sagemaker stands in the machine learning stack. Here you can see Sagemaker is in the mid layer of our AWS ML services, and the top layer, as JP mentioned in the call today, is usually services for developers who don't have a lot of data science experience, where they can use for any given problem that they have, they can easily start building and deploying a model. Whereas with Sagemaker, it's more defined for data scientists, data engineers, ML engineers, and MLOps people who want to train a model, perhaps with a little bit more diving deep and also having more flexibility around what they can build with it. So, like you mentioned, machine learning workflow is quite iterative and it can be complex sometimes. You have to collect data, and once you collect this data set, you have to pick a model that is going to be most suitable for the problem that you have. Moving on, you have to train and tune this model, and for training your model you have to pick which environment that you are going to be using. You need to provision this environment, you need to think about the costs, you have to debug your model in most cases, and then you have to continue with deployment. And once you deploy your model, it's really not the end of the story. There are a lot of different ways that you can go when it comes to model deployment. And even after you deploy your model, you might have some problems. For example, your data might change. So your model evaluation metrics are not going to be good enough as they were in the past. So you will also have to do model monitoring, which is frequently forgotten by most customers. So these are some of the things that we have to think about when it comes to an end-to-end machine learning solution for our problems. And basically this is Sagemaker covers most of these problems. Starting with data collection, you can use Sagemaker grant root to label your data. And if you have security concerns, you can also keep your data within your company and only give labeling tasks to your personnel as well. Additionally, for building your machine learning model, you have a lot of sample notebooks that you can start with, and if you don't want to use the already existing built-in algorithms or notebooks, you can bring your own model via a Python SDK or bring your own container and deploy that as well. Working on with the training and tuning part, for example, the most time-consuming part for me while I was applying for my job for AWS, I was given an assignment, and I wanted to do hyperparameter optimization. So I decided which model that I was going to use, and I picked some parameters, but I was wondering whether if it was going to be better in terms of accuracy or RMSE before I submit my application. So what I wanted to do was a hyperparameter optimization, but it took me hours. So I picked up my range of parameters that I wanted to search within, and it tried all of these different variations, and it took for me 4 hours to finish this. And for a university student, is quite a lot of time that you can spend on studying exams. So with Sagemaker hyperparameter optimization, what you can do is it creates a separate instance from your notebook, so you can actually continue working on your instance, and it's parallelize multiple different instances, and it allows you to parallelize the work. You forget about it until your results are ready, and it's an optimized search. So it was once I first discovered this Sagemaker HPR job, I was quite happy with it, I must say. And once you're done, most of the time, this is the POC phase of a project. You have your problem, you collect the data, build a model, and you end up with some metrics that you're quite happy with, and now it's time to go to production. And once you go to production, you have to decide what kind of a solution that you're looking for. Are you going to look for Are you looking for a web application or mobile application where you will need a persistent endpoint, or are you looking for something like a training that is going to happen only once a week? So you can do a different sort of model deployment in that case. And additionally, it's very likely that your model data will change. So for example, currently I'm working with a fashion retailer customer, and their data changed after COVID. So now their sales numbers are quite different than they used to be. Certain items sell more, certain items sell less. So given this, they need to retrain their model. So they need to be able to regularly monitor their model in production, and they need to take actions accordingly, given there's drift in model metrics. So for all of these reasons, Sagemaker is quite a good solution that any data scientist, data engineer, or MLOps person can use. It makes using machine learning quite easy. It's quite scalable. You don't really have to think about whether if my model endpoint is going to scale. You just define your instance type and minimum and maximum number of instances that you're willing to spend for that endpoint, and it will scale it automatically given the demand for you. Also, it's quite cost effective because you can use many spot instances. So imagine you're a company in bioinformatics, and you have to run a lot of tests. But perhaps some of these tests are not very important, very immediate, so you can use many spot instances to run your tests while the instance prices are cheaper compared to the other times. Security is job number 0 in AWS, and with data science, if you have data, it means that you are very likely have to protect it. So with SageMaker, you can build your model in an isolated network or in a network that only your production pipeline is going to be using. So it also allows you to build quite a secure pipeline.
You also mentioned that you are able to connect to your own environment, right? Just to add that layer of confinement as well, and train your models from that?
Exactly. So for building your model, you can have an isolated network. So your model will only have access to certain things that you're allowing it to, potentially the data that is in S3. And also nothing else has access to your model as well, unless you deploy it in an endpoint where you will be given a secure HTTPS endpoint, where you can use that to communicate via an API from your web application or mobile application.
Okay, interesting.
So moving on some of the SageMaker's key features, I will be mainly focusing on the training and deployment features. So there are a lot of built-in algorithms that you can use. So for example, one common algorithm that I tend to use is DPR for forecasting. So for example, for my fashion retailer customer, I'm using DPR because it can take thousands of related time series, which is going to enable you to have predictions quite fast. And you don't really have to go through the hustle of training a custom deep neural network yourself. A lot of the things are already given it to you, so you can have one-click training and one-click deployment with Amazon built-in algorithms. And as you can see, there are quite a lot of options. However, if you want to bring your own algorithm, that's also possible via a Python SDK, or you can even bring your own container. So when it comes to training, there can be a lot of different things that you might want to consider. For example, your data set might be quite large. So you might want to stream your data to your model, and that's also possible with SageMaker. It's not really memory bound, so you can train any sizes of data sets. You can also use Spark within SageMaker, and you can use, for example, PySpark to train your model as well. So it also allows you to have a distributed training job as well. Moving on to my old problem, hyperparameter tuning. It has an algorithm inside of it which allows you, it's a Bayesian search. So compared to traditional search algorithms like grid search or random search, it efficiently finds which hyperparameters are going to be the best ones, and it's going to create multiple instances in your SageMaker account, in your account that you're using SageMaker, and it will search for the best model. After that, you can go in to SageMaker's HPR job. You can see for yourself which parameters were tested and what was their performances, or you can just pull that information via code in your SageMaker notebook.
Is that something that you do once, or do you keep on tune that model? How does it look like that?
Yes, exactly. So, for example, with the current production pipeline that I'm working for this fashion retailer customer, we have 5 different models, and we deployed all 5 different models in parallel. And every week we do hyperparameter optimization on them, because the data might be changing, so the parameters might be changing over time. So we are triggering HPR jobs before we go to the production with the model. So it's really up to you on how frequent that you want to update your model. For example, for F1, we did something like picking which hyperparameters that we're going to use in advance, because we had to predict with millisecond latency. So for that case, you don't really have to have the time to run an HPR job. So in the background, you check whether if your model is performing well after a race is finished, but during the race it's not really possible. So we just go with the pre-predicted HPR parameters. Yeah. So it's with SageMaker, your deployment is quite easy. It's like I mentioned before, it has auto-scaling capability, and for example, if you're using an application where you need a persistent endpoint, you can go with SageMaker endpoints, where you pick the instance that you want, and you say deploy, and then you just wait for a couple minutes, and then you see your endpoint deployed with an HTTPS point that you can use for your application. For example, for my current customer, they don't really need their model to have a persistent endpoint, because they don't really have time to arrange their stock real time. So what they want is something that runs every single week. And for that, to save costs, what we're using is batch transform. So you train your model, you save it somewhere, and once you want to do inference on it, you can reuse your model that you already saved. However, if you were to need something more real-time, then you could go with endpoints. And SageMaker is also not the only solution out there where you can deploy a model. For example, like I mentioned, F1, we deployed our model to Lambda because we needed that millisecond latency, where we wanted our entire pipeline to be serverless. And you can also use containers if you have very large custom models as well.
Many choices, interesting.
Yes, so actually, I want to wrap up with what are some other services that you can use hand in hand with SageMaker, so you can have a full pipeline. So I call them MLOps-friendly services. They can be used for all sorts of things, not only machine learning, but for a data scientist, these are the daily use cases for them. So with Code Pipeline, you can build your CI/CD pipeline. So what I really like about a final solution that we deliver to our customers, for example, I was working with an energy company, and they wanted to have a solution that retrains every month. So what we wanted to give them was a full pipeline where their data scientist makes a change and they push their change to code commit, or you can also do this to Git or Bitbucket. And what happens after that is it triggers your pre-processing pipeline. All the defined pre-processing functions starts running. Once they are finished, your training job starts. Once your training job starts, you have an endpoint after that, or you have a batch transform in a container or in S3. And then after that, you can do inference to that model. So you have your inference pipeline where you can have requests to the model, and then you get predictions back. So with Code Pipeline, you can build the CI/CD. Where with Code Deploy, it allows you to actually deploy the code itself to Lambda or to Fargate or anywhere else that you might want to run your model. So if you see Code Pipeline, it usually goes hand in hand with Code Deploy. Finally, it's unlikely that your data scientist will go to the console, click, 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 and then build the model in SageMaker, click, upload data to S3, and then, oh, let me do inference, and then click again. What happens if you do this in your dev account and you want to redo the exact same thing to prod account as well? Are you going to go back to the console and rewrite every single thing? It's unlikely, and it causes you to write a lot of documentation. For that reason, you can use CloudFormation, which is infrastructure as code, where you can define every single resource that you're looking for with their access rights, like their roles, and then you give permission to these services, and you only deploy your code, and this code is going to create all of those resources in your AWS account for you. So we usually write a CloudFormation or something like a CDK or SAM for our customers, where they end up with their infrastructure as code, where they can deploy this to multiple availability zones and also to their dev account and also prod account. And this is something that these step functions they're quite fun to watch, actually. They look like a tree, and they allow you to build work streams. So imagine that you want to build this entire pipeline with pre-processing, with model training, and with hyperparameter optimization and model deployment. You will have to wait a lot, right? You will have to wait for your pre-processing job to finish, and then you will have to set up a notification for your training. Hey, my pre-processing finished, please start. And then your training starts, and then you wait for your training so you can do your inference. Whereas with step functions, it looks like a tree where the mother node is the starting point. It says, start my pre-processing. And you start your pre-processing job. It can fail, so you put another node to that tree and say, if fail, send a notification to Naz, so she fixes. And then if it passes, then move on to the training job. If training fails, again, message Naz and explain her why it failed, send the error. And if not, you can do your inference. So with step functions, you can write these in CDK, and it allows you to build these workloads so that you can build your solution step by step.
Nice.
Great.
Can't wait to start with Sagemaker, right?
I'll definitely check it out, yeah.
So how do I start, Naz?
Yeah, so there are quite a lot of resources. So you can go to Sagemaker examples, where there are tons of notebooks that you can start. And it really feels good to see someone else wrote the code for you already. And you can check if you have any problems, the developer guide, where we have a lot of documentation. And you can also move on with the SDK documentation if you want to bring your own Python model as well. Additionally, if you like watching videos, we have video training series. There is a 10-minute tutorial, which hint takes 1 hour to complete. And then there are quite some online workshops that you can follow to get started. And if you want to show off to your employer that you're now an expert in AWS, there is the machine learning certification that you can take. It covers almost all of the basics for machine learning, deep learning, as well as AWS services around it.
Great. Great. Well, wonderful presentation. You not only showed that it's a really iterative process, but it's this whole orchestration that is being supported with not only Sagemaker, but also the MLOps resources that you showed. Well, thank you very much, Naz.
Thank you, Naz.
Yeah, thanks, Naz, for having me.
Yeah.
Wonderful.
Awesome.
Yeah.
Yeah. Great.
I'll definitely check it out. I'd like to do the tutorial that takes an hour.
Yeah. It's supposed only to be 10 minutes, yeah. No, I really like, again, right, how Naz shows us how it's part of a larger set of services that you can just add to while your use case progresses, right? You start out simple, but then you blow it up, but in a secure way.
And as we also heard earlier, I mean, you end up paying less and actually doing things faster. So there's really very little downside to it.
Yeah. Yeah.
Cool.
Thanks.
Thank you very much.
Yeah, thanks a lot for having me.
Next, here to talk about 5G and mobile edge computing is Sohan Maheshwar. Welcome.
Thank you so much. Thanks for having me.
You are a developer advocate here in Amsterdam?
Yes, that is correct.
All right.
Yeah, so you're going to talk about 5G.
Yes.
So what can 5G bring us?
Yeah, well, 5G has been in the news quite a bit, Reinhold. Not for the right reasons, I might add. But all of that is not true, 5G is rightly, I think, in the news for, really furthering mobile applications. It stands for 5th generation. And when it comes to cellular networks and speed and latency and bandwidth, it's the next phase. All of us use maybe 3G or 4G, but 5G is going to take us to the next level. So that's what I'm here to talk about.
Interesting. Yeah, I can see all types of new possibilities emerging with this higher bandwidth, right?
Yeah.
So I can imagine that Amazon and AWS want to take advantage and provide services for that as well.
Absolutely. So from a personal point of view, I've always worked with future-looking technology. Before this, I was in the Alexa team. So I worked a lot in the voice space. Before that, I was in the chatbot space. So I really like to look at the future. And I genuinely think that our tech experiences will be sort of defined by 5G going forward. And there are a lot of countries where they rely a lot on just mobile networks. So, you can really sort of push the boundaries with 5G.
Yeah. And the combination of 5G and AWS, what's future forward-facing applications do we talk about then?
Yeah. So I told you what 5G is. AWS provides infrastructure for something called mobile edge computing. What this essentially means is you're bringing cloud processing and cloud computing as close to the edge of the network as possible. So what this essentially means is when, like, say I use my phone to make like a Uber call or whatever, it goes from my phone, like say I have a Vodafone connection, to the data center of Vodafone, which then goes over the internet to, like, say, an AWS region. And your processing is happening there. Your application processing is happening there. So that means there is a latency, right? You are depending on the internet. There is some time, there is some latency. With mobile edge computing and edge computing in general, you're sort of bringing that compute or that storage as close to the edge as possible. So with some of the options that we will speak about, we will show you how you can bring storage and computing to a data center straight from your phone.
Yeah, great. So you have a number of characteristics on mobile edge computing, right?
Yeah. So essentially, I want to talk about how 5G, it's going to be big in, like, say, 3-4 years. You will have proliferation then. And I think this drives a whole bunch of new use cases. You'll have cloud gaming, you have video streaming in really high quality, you have AR, VR, which is augmented reality. Just to give you an example, if you take augmented reality, for example, I point my phone this way, I'll have to wait like maybe 5 seconds to say, okay, this is Oyster Park. Then I move it around like 5 more seconds, okay, the pipe is that side. It takes a while. It's not a seamless experience. But with 5G, you really get that high bandwidth, low latency to give you live information of what you're looking at, to truly get augmented reality. And this new use case, again, dials into mobile edge computing, which again goes back to 5G. So that's really the business model that everyone is looking at right now.
Wow, interesting. And so I can imagine that there will be a huge number of devices on the network, right?
Absolutely.
So how to handle that?
Yeah, so there are going to be a huge number of devices, which means there is a huge amount of data. And you don't want all of this data that's being processed only in the cloud. That's only going to increase your latency, which is why you need some of that compute, some of that processing a lot closer to the edge, which is what we're here to talk about.
Oh, okay, yeah. So to decrease that latency, you move it closer to the actual device.
That is true.
Using it. Okay.
So you already mentioned a use case, but what are some of the use cases for?
Well, yes, well, that's a good question, because honestly, I see use cases everywhere.
Yeah.
Everything from something like healthcare, where you have real-time diagnosis. When, maybe you're doing like a colonoscopy and you have like a camera feed and you can get a real-time diagnosis of what's happening using AI/ML models. Previously, my colleague Luke spoke about sports insights. Are you guys sports fans?
Yes,
sure.
Yeah. So imagine watching a game in a stadium and getting those live insights right then and there. Like saying, okay, there's a good chance a goal is going to happen, or something like that to increase your excitement. There is, of course, AR, VR. There's also things like connected vehicles. Everyone's talking about self-driving and autonomous vehicles, but you need really, really low latency to be able to achieve that, which is what 5G and some of the AWS services like mobile edge computing really enables.
Yeah. Cool. And so to support these use cases, what type of solutions does AWS offer for the edge?
So AWS has a huge suite of services and infrastructure for mobile edge computing in general. And I'm here specifically to talk about something called Wavelength. You might be familiar with some of the edge computing solutions such as IoT Greengrass, Sagemaker Neo, which enables you to run machine learning models at like 1/10 the memory, like Alexa voice service, for instance, like RoboMaker. We also have some infrastructure services such as Outposts, where you have like an on-premise solution, but you want to run AWS services on that, so you use Outposts. You have something called local zones, which are, I'm sure you know that AWS runs in regions across the world, right?
Mm-hmm.
In 24, if I'm not mistaken. But there are areas where there's like metro cities where there might not necessarily be a region, but there's high usage. So you bring something called a local zone there.
Yeah.
And what I'm here to talk about is Wavelength, which is infrastructure specifically for cellular service providers running 5G.
Yeah,
so you're bringing,
The customer expectations must be really high, right?
Yes, absolutely. Because customers, they want a cloud-like business model for that. They want, of course, they want ultra-low latency, but they want simplified management. They want fallback. If something goes wrong, it has to fall back to a region. They want new features, and they want deployment like how you would with a traditional cloud system, like CI/CD pipelines, etc. And right now, none of that exists. And customers really want that to say, hey, this is what we're going to invest in.
And Wavelength fills this
Absolutely,
gap.
yes.
Right.
Okay. You already started about Wavelength.
Yeah.
It's a AWS Edge platform. Can you dive a little bit into detail in that?
Yes, so like I said, Wavelength is about infrastructure specifically for CSPs or cellular service providers who are running 5G. So essentially that's what it does. It brings storage and it brings compute closer to your cloud.
Okay, and what are, you mentioned it's a platform. There are parts of it. You mentioned already the local zone, AWS Wavelength, the on-premise facilities. I think we have a slide about that as well.
Yeah. So this is the suite of services for AWS Edge Computing. Like I mentioned, if you look on the right-hand side, you can see everything from IoT Greengrass, which is deploying IoT devices on scale. You have Storage Gateway, which is if you have on-premise storage and you want to access some of the storage options on AWS, you can use that. We have RoboMaker, which is if you want to deploy a fleet of robots. I recently bought a RoboVac, so I'm sort of like trying to figure out how, like it still blows my mind. This thing is like helping clean up, etc. You have Amazon CloudFront, which is a content delivery network, but you also have SageMaker, Kinesis, Alexa voice streams. Now these are AWS services for Edge.
Yeah.
But we also are talking about infrastructure specifically for Edge. So if you look on the left-hand side of the screen right now, one more, you will see the infrastructure services. So like I said, local zones are for areas like large metros where there might not be an AWS region, but there's a lot of usage. So you have a local zone. Similarly, you might want an on-premise facility to access AWS services, so you have AWS Outposts. And finally, for public mobile infrastructure, we have AWS Wavelength. And Wavelength really brings this storage and compute, and it solves a lot of the challenges that we spoke about earlier when it comes to deploying 5G applications.
Nice. So this Edge platform, you already mentioned a couple of details about that. Can you dive a little bit into detail about that as well?
Yeah, absolutely. I think this is important because it's not just something that will interest just an enterprise, or it will not just interest like a Verizon or a Vodafone. Even if you're a startup, even if you're an ISV, deploying to 5G is going to help you. So what Wavelength essentially does is it brings storage and compute closer to to the edge. And you can also not just use storage and compute, but you can also access other AWS services such as DynamoDB or S3 or all the other services. And it also gives you the option of falling back to a region if something goes wrong. So say someone is trying to access storage or compute in a wavelength zone and something doesn't happen, something goes wrong, that can happen. it also gives you an option to fall back to a region to serve that same thing, like a fallback. So that is another feature of Wavelength as well. And at the end of the day, it gives you like a single pane of visibility into managing everything. So you can you can deploy the same application to a region and a wavelength zone and have a single pane of management for all of it. Just to give you some sort of difference, it is different from outposts and local zones in the sense that this is specifically meant as a service for 5G networks.
Okay. So you mentioned Wavelength now a couple of times. Perhaps we can talk a little bit more specifically about the product. Can you explain? You already mentioned how it's different from the other services. Can you explain us what Wavelength is?
Yeah. So Wavelength, essentially, like I said, it's compute and storage infrastructure from embedded inside the cellular service provider. Very often you don't even have to go outside of the connection between your phone and the data center of your cellular service provider. So just to give you an example, someone like a Verizon or a Vodafone will install a Wavelength zone in their data center where the storage and compute happens.
Okay. So and this all to reduce the latency, right?
Yeah. So like I said, you're reducing latency, you're having ultra bandwidth. Wavelength actually is very dependent on, in general, actually 5G is actually like slightly dependent on hardware. You need the infrastructure in place. So you can actually just develop applications once and deploy it for use in 5G networks globally. And like I mentioned earlier, you have failovers implemented in Wavelength as well. So for instance, if something goes wrong in a Wavelength zone, you can fall back to an AWS region to run the same storage and compute that you would otherwise run.
But I can't imagine that you would run your whole application on the edge, right?
Yes.
How does that work?
Yeah. So you're not going to run all your applications on the edge. You would look at things that might take slightly more extensive compute or, to reduce that bunch of latency. So things like you would typically run on an EC2 or some block storage on an EBS that you would typically run on a region, you can now move to a Wavelength zone within a data center.
Okay, so you can actually pick and choose what to optimize.
Absolutely. And you can still access other AWS services like DynamoDB and S3 using a Wavelength zone itself.
Okay. Wow, that sounds really useful. Also, the ability to be able to choose. How about the ultra low latency to applications? Do you have a slide about how that looks like?
Yeah, so I want to show you how it would typically work with and without Wavelength. So currently how it looks like is this, right? So you have your phone on the left-hand side, which typically if I make a call or I use my data, it goes to the data center of my network provider. Like if I'm using Vodafone, it goes to my Vodafone network, my Vodafone, data center. This doesn't need an internet connection right now. From there, it uses the internet to go to, like, say, an AWS region where some processing is happening. My app is running in AWS. So the latency between A and B that you see on the slide is fairly high. It could be up to 180 milliseconds, depending on your network and other factors. Where Wavelength really comes in is instead of running that compute in that AWS region, you're bringing it closer to the cloud. So if you look at the slide right now, the round trip time between A and B right now is reduced. It's much, much lesser because you don't have to rely on that internet connection to go to that AWS region. You're bringing that compute as close to the edge as possible.
Yeah, so you're only talking about really the left side of the interaction. Yeah. Okay. And how about the so you have the latency to reduce, you don't need to traverse the internet, stay with the mobile network. You also mentioned predictability. What do you mean about that?
Yeah, so if you look at the top diagram, between the data center and AWS, that isn't the most predictable amount. It's not completely deterministic because it depends on so many factors, right? How many people are using it, what sort of connection you have. That can vary a lot, which affects performance. And you would have seen this when maybe you're streaming something on like a Netflix. Sometimes you might have a super high bandwidth on your system, but you might get a lot of buffering in the beginning because it's trying to figure out how fast your internet connection is to serve something to you. But with Wavelength now, because that unpredictability is removed, because if some of that compute and storage is happening between the data center and your phone, right, or the cell, that is predictable.
Yeah.
So you're making your time taken to serve something a lot more predictable.
Yeah, and you can also, because it's really, Nas also mentioned that you can iteratively improve stuff. If you see that something has too high a latency, you can try to push that to the edge.
Yes, absolutely.
Okay. And what are the core services of AWS?
Yeah, you can use the core services like EC2, EBS, EKS, all of the famous core services that I'm sure you're familiar with. But you can also use the other services and tools in that same region. Wavelength zones deploy to a region, but if that region has support for S3 or for DynamoDB, you can use those as well.
So if I wanted to know more about a Wavelength, where would I go?
So AWS Wavelength actually was released very recently, like I said. This is future looking. Yep. I'm not telling our viewers to go change everything today and deploy everything to Wavelength. It is something to get started on. It's something to get you thinking. Yep. So it's running on private beta right now. So if you go to our documentation page, I have a list of resources.
Excellent.
I've specifically put this in because I want people to read about it a little bit, as opposed to, this is not something that's been there for like 10 years.
Yeah.
Right? So do your research, see how it helps your business, your startup, whatever. These resources will be a good starting point to get you started.
Excellent.
Yeah, so you're actually offering people a new journey, right?
Yes.
So with 5G, not entirely there yet, but on the horizon, you're already trying to, like you said, face forward, look forward into the future, how to use that new possibility.
Yeah, I think tech moves so fast these days, Honestly, technology moves so fast that you have to always look at what's coming up next. Yeah. You can't rely on, hey, this has worked for me in the last 2 years, I'm going to be happy with this. You have to look at innovating, you have to look at what's next and how that can help your business. And I think looking at Wavelength and 5G is definitely something you should do.
Yeah, I can imagine that it will actually change the way machine learning engineers look at the world, right?
Yeah.
They don't need to optimize only for local efficiency and latency. It's also it broadens the picture.
Yeah, it does. Yeah,
deploying your models on 5G adds a whole different dimension.
Yeah, it opens up so many more doors.
Definitely.
Yeah. And also the amount of data and the type of data you can collect and sort of ingest. I mean, that only becomes bigger.
Yep.
So
Yeah, with IoT being served with this, I mean, new types of business opportunities will arise next to the technical challenges that we focus on, of course, here more. But I can see how it's, like you said, it opens up new ways for your startup or, your grown organization to improve your products and services as well.
Right.
Okay.
Thank you very much.
Thank you so much for having me.
Yeah, great to have you here. And this is...
you can follow me on Twitter.
Excellent. Thank you.
We will.
All right.
Thanks, Sohan.
Thank you. This was fun.
Great.
And that brings us to the final topic of today. Here to talk to us about cloud control is Hélène Versloot. She is the Director of Operations at Binx.io. Hélène, welcome.
Thank you very much.
Hey, good to have you here.
Hi, Jesper.
Hi.
Yeah, unfortunately virtually, but glad to be there. Yeah.
Yeah, I mean, it's challenging times, right?
Yeah, we all know it, right?
Yeah, but great to have you nevertheless. So, in your role, I can imagine that you get quite a good overview of what is happening in the cloud at organizations in general. What do you see when it comes to cloud at the moment?
In my experience, nowadays almost every organization is working in the cloud. And that might not always be a public cloud, that could be private or even some sort of hybrid cloud. But we do see everyone shifting towards the cloud or already working in the cloud. Which means that organizations are shifting their internal IT from more the traditional system management to software or cloud engineering with really that end-to-end responsibility. And especially in the bigger organizations, we see a shift from one centralized internal IT team to several teams throughout the company working with the cloud, sometimes even working with different clouds or different cloud environments within one organization. And obviously that creates quite an interesting environment for innovation, and it really allows the specific teams to support their own needs for their part of the landscape.
Yeah, so again, the end-to-end responsibility in combination with best practices around software, infrastructure as code, that you see that transition going on at the moment.
Yeah, and especially the decentralization from where you would have one core IT team, and now all the teams have business and IT really close together, so it's more decentralized within one organization.
Yeah. And of course, working within cloud, this transition already going on, but also a lot of services popping up quite frequently, sometimes even weekly. I see cloud quickly expanding to other teams within the organization as well. Can you give a little bit of insight on that, perhaps?
Yeah, sure. And as I just mentioned, within one organization, you would see multiple teams working with the cloud, working with their part of the cloud. And because of that, it could take a lot of time to really get control of your whole landscape of your cloud environments. And organizations often miss out on new features, or not all the teams take the same amount of effort to continuously optimize their cloud workloads. And a really important factor is knowledge, because if not all the teams are on the same level of knowledge or do not have the same access to information about new services, you will see that in the end, they are not using their cloud environments in the most efficient way. Mm. And another challenge that comes with the rapid development within organizations and within the cloud is that if multiple teams use their own cloud environments, this means they all have their own account or even multiple accounts, and they all have their own access to the cloud or to their specific part. And most of the times, those multiple accounts are connected to different credit cards or different invoicing systems or different reporting systems. And it might be really complex to gain insight on the organization-wide cloud consumption. And this, of course, could also be challenging from the cost control perspective, because it's not easy to allocate cost if you do not have a complete overview of your cloud consumption and your landscape.
Yeah, yeah. Can you share an example of an organization that went through this journey, this cloud usage journey?
Sure, I can even share an example which is still ongoing, because I'm not sure if this is something that really stops. So, for example, we have Pathé Theaters from the movie theaters in the Netherlands. They moved to AWS, but did not have all of the cloud expertise and knowledge in-house in their own team. They do, however, wanted to accelerate the adoption and speed of innovation. So with our expertise and knowledge, we help them to get control of their environment, make sure that they have the knowledge they needed to maintain it and to keep it up and running. And at the same time, we help them and are still helping them to make sure that the costs are in control, that they know what they can expect on their next invoice, and that they know if the team is moving in the landscape and they're using a new service, that they know what kind of cost they can expect.
Yeah. Perhaps it's good that you dive into a little bit more detail on how you would advise organizations to stay in control of that cloud and the associated costs.
Yeah, sure. I think, or even in my experience, the first thing to do is to start collecting data. after all, it is GoDataFest, but the data on your cloud consumption, and not just one specific team, but start monitoring your complete cloud environments and make sure to detect any anomalies that are there. So make sure that you know, even if it's multiple accounts, there are ways to make sure that you have all the data from that account centralized, and from there get a good overview of the cloud consumption that you use. And when you are working towards that centralized data, we always advise organizations to start using centralized billing. You don't want multiple credit cards going throughout the company, multiple ways of invoicing, not knowing who is going to use what. You want all the different cloud vendors, all the different workloads on one invoice. And with good reporting, you can easily get an overview of the total consumption, so within the whole organization, but you can also zoom in whenever you believe that is necessary. So whenever you see costs that you didn't expect, or you would see different teams using the same part of the environment but in different ways, you could detect all kinds of differences in between and zoom in wherever you need. But the finance department just has one invoice and can really use that. And I think, as I just mentioned, knowledge is key. So last but not least, my biggest advice actually would be make sure to stay on top of AWS in terms of knowledge. Make sure that every team, if it's centralized or decentralized, knows what is going on within AWS. What are the new developments? What are the new services? And how you're going to use that knowledge. So make sure that the team is regularly trained, or they share knowledge in between the teams, and that they sync that if they're going to use a new service, because perhaps another team wants to join in as well. So really make sure that the knowledge on the cloud you're using is not something that's kept within one team, but it's decentralized within the company as well.
Yeah. So control for you is not only control on what to use in which cloud or the costs, but it's also staying in control of the development. It's a whole package, I understand.
Yeah, it's really staying. AWS is constantly improving, and if you want to make sure that you're using the cloud in the most optimal way, you really need to stay on board there and move with them.
Yeah. So awesome. So how can people or organizations start with these services from you?
Well, it's actually quite easy, because we have developed some tooling that it could easily get access into the data of multiple accounts without getting access to any of the personal data that is on the cloud environment. It's just the data on the usage. And we could really help them to set up the monitoring and the reporting. And at the same time, with all of the knowledge we have and with all of the direct access we have within AWS, we could help them to optimize their cloud environment. So we could analyze the data just for a couple of weeks or a couple of months to see where all the anomalies are, and to advise them on to maybe use different services, new services, or to really optimize their cloud usage.
Yeah, so it's a really frictionless start, because you have this package already available for the customer, but then you can tailor towards a specific solution for a specific customer and specific use cases. Is that correct?
Yeah, and I think the most interesting part is that we are actually helping them tailoring their own solution. So it's not that we're going to tell them how to use it, but we're helping them set it up and get control of that cloud themselves and advise them along the way. We're not telling them how to do it, or we're not telling them how to keep control, but we're giving them all the information they need and the advice from us to get control of that cloud and stay in control, and not just use it for the moment, but continuously stay in control.
Ah, I really like that because from experience, we also see other organizations making other choices and really giving away a lot of control, having to call faraway customer centers to get something rolling. It's you take away part of the worries around control, but still the keys maintain with the customer, right? With the organization that chooses your product.
Yeah, and you can give different stakeholders the information they need, because if you look at a finance department, they just want to make sure that they know what to pay, so they know what's on the invoice. They don't want surprises, and they want to be able to allocate the cost. So they don't want a lot of detail, but just enough. And we can help organizations with that.
Yeah,
great,
wonderful. Thanks very much, Elaine.
Elaine, thank you for being here.
Thank you for having me.
It's been illuminating. So thank you. Yeah.
Thanks.
Thank you very much.
And hope to see you live real soon again, Elaine.
I hope so as well. Thank you.
Okay. Bye-bye.
Bye.
Bye-bye.
And that brings today's session to a close. Today was all about Amazon Web Services. We've heard some great presentations from experts at AWS, some wonderful applications from Knab and the Bundesliga. And I think this was a very successful first day. What do you think?
Man, I enjoyed it. Yeah.
Excellent.
I really liked it.
I would like to thank you for being here and being my co-host, also the first one. I mean, a big thank you to today's sponsor, AWS. Thank you to all of the speakers. You were really great. And of course, to our viewers, thank you for watching. We have a great program for the rest of this week, so make sure to tune in for the next 4 days. Thank you.